Hello everyone, welcome back to the data structures lecture series. In the previous lecture we have seen the introduction to stacks. Now we are going to implement the stack using arrays. Okay, there are two ways to implement the stacks. One is implementation using arrays, implementation using linked list. Now we are going to see implementation using arrays. Before going to discuss that, let us see the definition of the stack. Stack is a linear data structure and it can be defined like this. We will perform both insertion and deletion operation on stack from the top only. So always from the one end only. Okay. So the other end of the stack is closed. We will do operations from the top only. Okay, it seems like a bucket. Okay, now it always follows LIFO principle, that is last in first out. Okay, so whenever you keep books, okay, you used to keep all the books one by one on top. Okay, whenever you want to pick a book, we usually pick the top book. Okay, then in the same way, whenever you keep data elements in stack, okay, we can pick the last element that is inserted into the stack first. Okay, so that is LIFO principle, right? Stack operations, there are three operations, okay, we perform on stack. One is push, inserting element into the stack; pop, deleting element from the stack; it is an optional PEEP, displaying the top element. Okay, right. Now let us see the implementation of push operation using arrays. Okay, right. Before discussing the implementation, I would please take some assumptions that you have a array named as stack. Assume that you have an array named as stack and its size is 5. Here I am taking the same example, that is why take this assumption. You have an array of type integer with size 5, okay, declared earlier, right? And you have a variable called top, integer variable, and initial value of top is -1. Okay, now we will start the push operation. Okay, we will discuss about this if condition later. Okay, now we will see the else condition first. Okay, because see, in this if condition, the condition is top is equal to size -1. What does it mean? When this condition meet, okay, you used to display stack is full. Okay, now currently the stack is actually empty. Okay, you can see the size of stack is 5. So 5 minus 1 means 4. So when this top points to the 4, okay, then you can say that stack is full. Now stack is empty, actually not full, so we will see that condition later. Now let us see we come to the else block. Okay, and I want to insert a new element into the stack from the top. Okay, but top is not pointing to any of the indexes in the array stack, so let us increment the top first so that top will become 0. Okay, so after inserting element into the top, read an element, after incrementing the top, read an element, okay, using scanf statement. Let us say 10 is the value you read, then assign that value to the stack of top. Okay, so now let us see how will it be happened again. I am repeating the same. So increment the top will become 0 because initially it is -1, right? Then top points to the first index of the stack. Okay, then read an element into a variable ELE, place that in the stack. Stack of, what is top now? Stack of top is equal to ELE. What is top now? 0. Stack of 0 is equal to ELE. ELE is the value we read. Assume 10. Then 10 will be placed in the array. Okay, that is stack here, right? Let us insert another element. Okay, now current value of top is 0, so I am incrementing the top so that top will become 1. Now top points to the second index. Okay, then read a new element. Let us say 20 is the element value you read. Then assign that value to stack of top. What is top now? 1. So stack of 1 is equal to ELE. In the array, in the second position, you are going to place 20. Okay. Now do the operation again repeatedly till the top value is 4. That means you reach the top of the stack. Okay. So say execute the same code so that you can insert the elements into this. Assume that I have repeatedly executed the same push function 5 times so that my stack is full now. Okay. Now we will check the overflow condition. Okay. So what is the current value of top? 4. Okay. And here see this if condition. If top is equals to size minus 1. What is size? 5. So top is equal to 5 minus 1. 4 is equal to 5 minus 1. 4. So condition is true. So when condition is true, it meets the overflow condition. Okay. Then when overflow condition is met, it displays that stack is full. Okay. When that condition is true, it displays stack is full. Okay. So this is about push operation. Okay. We will discuss about pop operation. Okay. Now initially assume that we have a stack filled with 5 elements and the top is pointing to the 5th element. So index value of top is 4. Okay. And now what you want to do is you want to delete the item, top item. Okay. So before deleting the top item, let us display for the namesake, let us display the item we are going to delete. Okay. So I took that value stack of top into variable ELE element. Okay. And I will display ELE so that 50 will be displayed. Right. Now I want to perform pop operation. Okay. This is only the code for the pop operation actually. The first 2 lines are actually not required. Okay. But we are doing that only to display the element for our understanding. Okay. But the only code for pop operation is top minus minus. When top is decremented, top value will become 3 in this example. Okay. Now top points to the next index. Okay. Now tell me what are the value elements of the stack from top to bottom. Okay. So here from 40 to 10 are the elements of the stack. So 50 is not logically a value in the stack. Okay. So you can assume that 50 is deleted. Right. Similarly, if you perform this task multiple times, okay, you can delete the multiple elements in the stack. Okay. Now let us check the underflow condition of the stack. Okay. So what assume that I have only one element here. Okay, in this example, so that 0 is the index in which value is there. So top is pointing to 0. Right. So I will display that value 10. Later I want to perform top minus minus. That means the top value will become minus 1 so that top is not pointing to any of the elements in the array stack. Then you can say 10 is also logically removed. Now is there any element in the stack? No. So stack is empty actually. Now if you try to perform deletion operation, that is pop operation, one more time even though stack is empty, then what will happen? So you cannot delete elements from the stack because there are no elements in the stack. Then you have to display that stack is empty. Okay. So this particular condition is called underflow condition. Okay. When top is equals to minus 1, okay, then it displays stack is empty. Okay. That particular condition is called underflow condition. Now let us see the PEEP function. Okay. So what is PEEP? Assume that this is the stack you have. Is having 3 elements and the top pointing to the third element with index value 2. Okay. So now you want to display that, right? So take the element in from value into ELE. ELE is equal to stack of top. Display the same. using printf statement. The top element of stack is ELE. Okay, so it will display there, right? So this is PEEP operation. Let us see the displaying of elements of the stack. So displaying of elements of the stack will always start from top. Okay, so now see this for loop is used to display the elements of the stack. So I am taking an index I and I am writing I is equals to top, means I am starting displaying of elements from the top, because we always pick the elements of the stack from top only. That is why I is equal to top is the initial value. And here printf %d stack of I, so that I will be displayed. I mean stack of I will be displayed. So here top is 4 and 4 is assigned to I. Now I value is 4, so stack of 4 is 50. 50 is displayed, right? Then what should I do? I have to decrement the top. That is why I have written I minus minus. Okay, then I value will be 3 now. Top will point to index 3. Okay, now you are displaying stack of I, so that stack of 3, that is, will be displayed. Again let us say you are decrementing I, so top will point to the index 2. Then you are displaying stack of 2, that is, again that means that 30 is displayed. Again you are going to decrement I points to 1 and stack of 1 displayed, that is 20. Again you are decrementing I is now 0, so stack of 0 is 10 displayed. Again you are decrementing I, so I value is minus 1. Okay, now I value is minus 1, so you cannot able to continue this for loop, because the condition is I greater than or equals to 0. Okay, when this condition is true only you have to display, right? So here I value is minus 1, so the condition is failed, so you have to come out from the loop. This is how we display elements of the stack. If you have any queries, please write comment, or you can write a mail to me to this mail ID. I will reply for sure. And if you want immediate notifications after uploading a video immediately, okay, you just subscribe to my channel and just click on the bell button, so that you will get immediate notification. Thank you.